Michael Faraday was born into humble conditions, brought up in the Sandemanian sect of the Christian Church, and made his name in the scientific world, despite his lack of formal education, through his outstanding discoveries, observations, and experiments. His scientific work laid the foundations of all subsequent electrotechnology. From his experiments came devices which led directly to the modern electric motor, generator, and transformer. Michael Faraday was born on September 22, 1791. At the age of 14, he was apprenticed to a London bookbinder. Reading many of the books in the shop, Faraday became fascinated by science and wrote to Sir Humphry Davy at the Royal Institution asking for a job. On March 1, 1813, he was appointed laboratory assistant at the Royal Institution. There Faraday immersed himself in the study of chemistry, becoming a skilled analytical chemist. In 1823, he discovered that chlorine could be liquefied, and in 1825, he discovered a new substance known today as benzene.
Electromagnetic technology.
However, his greatest work was with electricity. In 1821, soon after the Danish chemist, Ørsted discovered the phenomenon of electromagnetism, Faraday built two devices to produce what he called electromagnetic rotation. That is a continuous circular motion from the circular magnetic force around a wire. 10 years later, in 1831, he began his great series of experiments in which he discovered electromagnetic induction. These experiments form the basis of modern electromagnetic technology. On August 29, 1831, using his induction ring, Faraday made one of his greatest discoveries: electromagnetic induction. The induction or generation of electricity in a wire by means of the electromagnetic effect of a current in another wire. The induction ring was the first electric transformer. In a second series of experiments in September, he discovered magneto-electric induction, the production of a steady electric current. To do this, Faraday attached two wires through a sliding contact to a copper disc. By rotating the disc between the poles of a horseshoe magnet, he obtained a continuous direct current. This was the first generator. Although neither of Faraday's devices is of practical use today, they enhanced immeasurably the theoretical understanding of electricity and magnetism. He described these experiments in two papers presented to the Royal Society on November 24, 1831 and January 12, 1832. These were the first and second parts of his experimental researches into electricity, in which he gave his law which governs the evolution of electricity by magneto-electric induction. After reading this, a young Frenchman, Hippolyte Pixii, constructed an electric generator that utilized the rotary motion between magnet and coil rather than Faraday's to and fro motion in a straight line. All the generators and power stations today are direct descendants of the machine developed by Pixii from Faraday's first principles.
Later work.
Faraday continued his electrical experiments. In 1832, he proved that the electricity induced from a magnet, voltaic electricity produced by a battery, and static electricity were all the same. He also did significant work in electrochemistry, stating the first and second laws of electrolysis. This laid the basis for electrochemistry, another great modern industry. Faraday's descriptive theory of lines of force moving between bodies with electrical and magnetic properties enabled James Clerk Maxwell to formulate an exact mathematical theory of the propagation of electromagnetic waves. In 1865, Maxwell proved mathematically that electromagnetic phenomena are propagated as waves through space with the velocity of light, thereby laying the foundation of radio communication, confirmed experimentally in 1888 by Hertz and developed for practical use by Guglielmo Marconi at the turn of the century.
Faraday the lecturer and educator.
Faraday was also the greatest scientific lecturer of his day, who did much to publicize the great advances of 19th-century science and technology through his articles, correspondence, and the Friday evening discourses which he established at the Royal Institution. He considered it a vital part of his job to educate the public on cutting-edge science. The Royal Institution Christmas lectures for children, begun by Faraday, continue to this day.
Later life.
In 1865, Faraday ended his connection with the Royal Institution after over 50 years of service. He died at his house at Hampton Court on August 25, 1867. His discoveries have had an incalculable effect on subsequent scientific and technical development. He was a true pioneer of scientific discovery.
Michael Faraday and the IET.
Faraday is a name of great significance in the IET. His statue stands outside Savoy Place, the London home of the IET, and his name is given to a major resource aimed at getting young people into science and engineering. We also hold an important collection of his personal papers in the IET archives. But why is Michael Faraday so important to the IET? After all, he died in 1867, 4 years before the institution was formed. Faraday's journey from unqualified apprentice to the most famous scientist of his day, his work on the fundamentals of physics and electricity, and his untiring efforts to promote science in society have ensured his legacy to the history of science and technology, and the importance of his name in promoting the IET today.